Hi, and welcome to this section on version control, and specifically on using Git. I'm afraid to say that version control isn't the sexiest subject to sit down and learn, and this chapter is quite a long one at almost 30 minutes. But version control is one of the really core basic skills you're going to need to be able to make it through the rest of the courses on this site. I've interviewed loads of people for DevOps roles over the years, and one of the things I look for in a great candidate is someone who looks relaxed and natural using Git. If they look like they've Googled it with their breakfast, it usually means they're an infrastructure engineer and they're not going to be a great hire. The other thing you might be asking yourself is, what is that operating system that I'm teaching on? And if you haven't looked at the section before this one, I go through how to install that and why it is we're using it. Okay, let's go and have a look at some of the features of Git. To illustrate why you might want to use version control, I'm going to show you a quick animation with two engineers. First, we need a traditional server from back in the day, and then two traditional engineers to use it, Kevin and Sue. Kevin writes a load of code on the server during his time with his company, and Sue does the same. Then, one day, Kevin mistakenly believes he's destined for better things and leaves the firm, taking all knowledge of the changes that he's made to that server over the years he's worked there with him. Now when Sue needs to fix the server, she realises she has no idea what Kevin's been up to or how to fix it. It's not that she's technically incapable of doing so if they're of equal skill level, it's that she simply doesn't know what he's done, and now she's screwed. This is the first of the key problems that using a version control system such as Git will solve. Whenever anyone makes a change to the codebase, there is a record of exactly what that change was, who it was that made it, and why, and I'll demo exactly how to get that information shortly. But version control has been around a lot longer than DevOps, so you might well be asking yourself the question at this point, why haven't companies been doing stuff like this all the time? I think the answer to that question is that until fairly recently it was standard for companies to buy their own kit and then rack it into data centers physically themselves rather than using the cloud. As recently as 10 years ago, I used to spend much of my time in Canary Wharf, messing around with the optical fibers of storage arrays and wondering if I'd ever see the sunlight again. Since the advent of cloud computing, for most of us the days of racking physical kit are over. Now we can define the entire estate as code, version control that code, and then spin it up exactly the same again and again, and have a record of who did what and why. I think that's enough talking about Git though. Let's go over to the terminal and have a look at how to install Git and how to use it. So first, let's open up a terminal. In the previous section, we just installed this new Ubuntu desktop on VirtualBox, so it won't have Git on it yet. Not to worry though, as we can install it using the command sudo apt install git. Apt is just the package manager for Ubuntu, so I'll be using it to install all sorts of things over these courses. And we'll just accept the install here. Now that's done, let's take a look at some of the Git commands. This might look like a bit of a daunting list to learn, but don't worry, as there's just a few key commands here that you're going to use in your normal working day, so we're going to focus on those initially. Clone is technically for cloning a whole repository, all the code and its history from a remote location, but I find it easier to just think of it as download code, as 99 times out of 100 you'll be cloning from the internet to your local machine. For this course, we're going to be using GitHub as the remote server to store code on, and one day when I have hundreds of thousands of listeners, I'm going to hopefully get a massive kickback from Microsoft for that. But at the moment, I've chosen it just because it's a big player in the market and it's free. In any case, just think of clone as download from GitHub for now. Add is for staging changes ready for a commit. Commit is for adding the changes you made to the code to the Git timeline. Push uploads those changes back to your remote server, and pull pulls any new changes, such as those made by another developer. Lastly, we have branch, though I won't try and explain what this is quite yet, as it'll be much more obvious when I demonstrate how it works shortly. Don't worry at all if this isn't making much sense yet, as we're going to take a look at each of these commands now in detail, starting with git clone. But first, before we do that, we're going to need to go and make ourselves a GitHub account, so we've got something to clone from. So, open a browser window and browse to github.com like you can see here. I've got an account already, so I can just click sign in, but if you do need to create an account, then all you have to do is pop your email address and whatever password you fancy in the box below, and you're good to go. Right, I'll just sign in here using my Lernard GitHub account. To give you some background into what we're up to here, Git is what's known as a version control system, which is essentially just a place to store code that you've written. It's quite possible to just run Git on your local machine, and you'd still get all the benefits of a historical timeline of changes that would allow you to roll back to any point in time that you committed your code to. But Git is also a powerful tool for collaborating with others, sharing that code and working on it together. With that in mind, people often have a whole server for hosting their Git-based code, so that lots of people can access it and interact with it at once. In this case, our code is being hosted by GitHub, much in the same way that Google hosts Gmail to provide a free email service, rather than you having to run an email server in your house. Unlike Gmail, however, GitHub doesn't make money by selling personal details about you online. They just host your code in the hope that one day you'll opt for a paid account, so there's really no downside to using a web-hosted service. Much of the code on GitHub is stored in public repositories that allow everyone to see them, and even suggest code changes and improvements to other people's code. This is known as open source and is a wonderful way to get the benefits of review from the wider code community, and some of the largest and most successful projects in the world are open source, including Linux itself. The name for a project that people store code in using Git is a repository, and we can see an example of a famous open source project on GitHub by visiting the popular Nginx repository here. Nginx is a web server and proxy, and all the code for it can be viewed by anyone, as you can see here. It has the same file structure and files as it would do if it lived on your computer, and GitHub allows you to browse around these using the GUI like so. All the code we create in these courses is going to be stored in Git repositories, or repos as I'll sometimes call them, and then uploaded to GitHub. There are plenty of other big players on the market, like Bitbucket and GitLab, so don't feel obliged to choose GitHub if you fancy shopping around, though for our purposes they all do largely the same thing. As we work through these courses, everything I do I'm going to upload to the Lernard.com GitHub public repo, so you'll be able to clone and work from that if you don't want to type out what I'm doing, or if you just want to use that code for a reference as you work. So, let's go and create our first repository to work with. First, go to the drop-down menu in the top right-hand corner and click Your Repositories. And, once this is loaded, let's click on the New button here. We're going to give our repo a name, a basic description, and then we can choose whether we want our repository to be public or private. For this example, it doesn't matter which you choose. In industry, it's good to always assume you want to pick private unless you know otherwise. That's not because it's better, but because making a repository private that should be public isn't a big problem and you can always change it. But making something that should be private public exposes it to the world, and there's no way you could know who's looked at it before you have time to make it private. Anyway, let's also choose Initialize this with a README, which will create a dummy readme.md file in our empty repository to give us something to clone. And now click Create Repository. So here we are with our nice new repository, initialized with a README in it, just as we asked. Now that we've created this repository in GitHub, we also want to clone a copy to our local computer. To clone, we just click the Clone button here and copy the URL, which we're going to use in the Git command line to clone it. Cloning is basically just a fancy word for downloading. It's called clone because Git is a distributed version control system, which means that everyone that clones the repo has a complete copy of not only all the files, but all the history of changes as well. That means a cloned copy acts as a full backup of the repository, and if GitHub were to be struck by a meteor, as long as you had the repository on your machine and up to date, you wouldn't have lost anything. Let's switch back to the terminal, and now type the command git clone, and then after it, paste in the URL that we just copied from the website. Notice that the URL starts with an https:// at the moment, which means it will ask us for a username and password. It's also possible, and probably recommended, to set up Git to use SSH, and the security is handled automatically by certificates. But for now, we're just going to use HTTPS because there's less setup, and we'll configure the passwordless system in the next chapter. Here we go then. Just enter your username and password you chose for logging into GitHub. And there we go. We've cloned our lovely new repo. Let's take a look inside this and see what's there. So, cd test to change directory into our test repo, and now I'll list the contents. And there you can see the readme.md file is there, just as it was in the Git repository when we viewed it in GitHub using our browser. There's also a .git directory, which we'll never need to touch, which Git is using to store the version history in, the record of all the changes that are made to the files in this folder. If I was to delete that .git directory, this cloned Git repository would just become a normal folder again. And conversely, if I were in a normal folder and I typed the command git init, then that folder would become a Git repo and one of these .git folders would appear there. Don't worry about all that for now. All we need to remember so far is that we've cloned our repo from GitHub, which has essentially downloaded the whole contents of the repo onto our computer. So, at this point, let's take a look inside that readme.md file. To do that, we're going to need to install an editor, as this is a new install of Ubuntu, so it doesn't ship with the editor that I personally want to use. Sudo apt install vim will get us the popular Vim editor. And there we go. Now that's installed, we can use Vim to look inside the README by typing vim readme.md. We can see it's got the title test, and then this is a test repository. If we now compare this to the file in GitHub, we can see that firstly the file is the same, and secondly, the contents of anything in the readme.md file are displayed on the front page of the repository. This is a handy tip, as it's a convention that almost everyone will write the instructions for the code they create in this file. So when you visit a repo, you can usually find the instructions for how to use the code on the front page like this. Okay, let's go back to the terminal, clear the screen, then learn some more Git commands. Next, we're going to take a look at add, commit, and push. To add code to a repository on our local machine, commit it to the timeline, and then push those changes back up to our origin repository on GitHub. First, we're going to make a new file in our repo. I'm going to call mine Kevin's file, and we'll pretend it was made by Kevin himself before his quest for greatness began. So I'll press I to enter edit mode, then add some random content here to pretend we've made some code. Doesn't matter what at this point. There we go. Now I'm going to save this file by pressing escape, then typing a colon, then WQ for write and quit, and then enter. As I said at the start of the basics chapter, I'm not generally going to go into much detail on how to do basic Linux things like using Vim like this. But in these very early sections, I'll go into a bit more basics than I would do in the later chapters where we start the proper DevOps. Anyway, if I list the contents, we can see we've created Kevin's file. Now, Git does things that an ordinary file system can't, and files that are included in Git have properties that files in an ordinary system don't. And so because of this, just creating a file isn't enough for it to be part of a Git repo. We also have to say, yes, I want this file to be part of my Git repository. At any time, we can type git status to see a quick summary of what's going on in our repo, like so. We can see here that this is telling us three things. Firstly, we're on branch master. Don't worry about that for now, as we're going to cover what that means in a minute. Secondly, we have one untracked file, which it tells us is Kevin's file, the one we just made. And lastly, it tells us we have no files to commit, which again, I'm going to cover in a moment. So, focusing on this concept of an untracked file, untracked means, yes, you have made a file in this repo, but you haven't yet added it to the Git system. At the moment, our file is just an ordinary file. Sometimes you might make a file accidentally, or you want to put some notes in your repo that you don't want to push up to the origin. So Git doesn't add everything automatically for us. We have to specify which files we want to be included. To add this file to Git, we're going to use the git add command. We can add files one by one if we want, or we can use a -A to add all the untracked files in one go. Now, let's type git status again to see what's happening. You can see now the file has changed to green. This means the file has been added to the Git repository and is now part of it. Notice now that the message above the file says, changes to be committed. This concept of a commit is really at the beating heart of Git. To commit means to save into the historical timeline of the repository. If you remember, I said that one of the most important reasons to use Git is that it keeps a record of all the changes that people made, and that those changes can be viewed on a timeline, and if necessary, the code can be rolled back to any point on that timeline. Well, to add code to that timeline, that's known as committing it. Each time a commit is created, it's creating a point in time that can be rolled back to, along with a record of who it was that made those particular changes and why. Let's do that now using the git commit command. Whenever you make a commit, you also need to write a message about what your commit represents, so you or anyone else will know what you were doing when you come back to look at it later on. So in this case, I'll just write, Kevin has made a change. Now, the first thing Git is doing here is asking who I am. This is because Git is not only a record of what changes have been made, but also who made those changes. Git is handily providing us the commands to do this, so let's use these now. First, let's copy this command to configure our email address. I'll just pop mine in here, but use whichever email you set up your GitHub account with. Next, we have to configure our name, which is also important to get right, as if your email address is badgirl69 but you're actually a 45-year-old man, it might be hard for your colleagues to know who made the commit without a real name to accompany your email address. So I could write Kevin if I were him, or in this case I'll write Lernard, as we'll be using the same account through all the courses. Now we've given Git the information it wanted, I can go for the git command again. And this time it's gone through. Now, if I check git status again, we get a new message that finishes nothing to commit, working tree clean. That's great, as it shows our file has been both added to the repository so that Git recognizes it, and then committed to the timeline with a message about what those changes were and who made them. You may also notice that it says we're ahead of our origin by 1 commit. This means that our timeline has changes recorded into it that GitHub currently doesn't. The word origin means where you downloaded the repository from. It's considered the central source of the code, and eventually all the changes that you make to the Git repo need to go back to that origin so that other developers can see them and collaborate with you on that code. So let's do that now. Originally we cloned the repository from GitHub using the clone command, and now we're going to push our changes back up to GitHub, which we're calling origin, using the push command. In this case, the command we're going to use to do that is git push origin master. You might well ask, why not call it git push GitHub master? And you actually could configure it to be like that if you wanted to. But as not everyone uses GitHub, it would be a bit annoying to keep changing commands every time you changed business, and they used a different product instead of GitHub. So the word origin has been accepted as the global term for the place that we're storing all our code and sharing it from. Everyone uses this, and it will be origin no matter where you go. So let's push this. Again, I'll need my username here and password. And there you can see it's uploaded our code. If we jump back to Firefox, you can see our original repository and README here. And if I now click refresh up the top here, you can see that now Kevin's file has appeared because we've pushed it up to the origin from our local machine. And if we look inside that file, we can see it's got our file content in there. For those of you thinking, what a massive load of hassle this all looks, I know it does seem a bit needlessly complex at first, but I've taught loads of people how to use Git face to face, and at first everyone is a bit bamboozled by it. But just like other complex things we do every day, like riding a bike or hiding our alcoholism, it will soon become second nature to you, and you won't remember a time that you ever tried to work without it. Now, let's go and have a look at how Sue might go and use this repository that Kevin has made to collaborate with him on his code using the git pull command. Okay, let's first make a directory for Sue. We'll cd in, and you can see it's empty, of course. Now, as I'm pretending to be Sue for this part of the exercise, we're going to clone this repository again for her. In reality, of course, it's already on this machine in a different directory, but let's just pretend it isn't. Okay, username and password again. And if I list again, you can see we've now cloned the repository into Sue's directory. Let's switch into it and see the contents. And as you'd expect, it's the same as the contents in GitHub, complete with Kevin's file. Now, Sue does some work too, by creating Sue's file. And again, I'll just press I for edit, write some dummy code in here, then escape, WQ, and enter to save. If I look at the Git status after doing this, then just as before, we can see the status of the new file is untracked. Of course, we know what to do with this now, so let's first git add to add the file into the new repository. And now we can see the file is waiting to be committed. Let's commit that file using the git commit command and an appropriate message again. Okay, git status again. You can see the file is being committed now and is waiting to be pushed to origin. A couple of points I'd like to make at this stage. Firstly, I really do type git status this much when I'm actually at work. When I'm committing lots of changes at once to a complex project, I really can't be too careful with what I'm doing. If I'm working for a bank or the government, a mistake could cost millions of pounds. And as git status is free to type, I like to use it as often as I can to make sure I'm not about to do something horrible. You don't want to be that guy that accidentally checks in a load of pictures of his cat, or worse, to a production repository, because that guy is probably going to get fired. The second point is that although I'm only working with individual files for this example, in reality you would tend to only commit to the timeline once a whole feature has been developed, so your Git history stays nice and neat. So, for example, you might commit after adding a new page to a website because it's one understandable unit of work. You probably wouldn't commit 10 or 12 times for each little change you made to that page as it muddles the history. Anyway, as we've seen all of this already, we can just push straight to GitHub, so let's get Sue's change up there alongside Kevin's. So, username and password again here. Now, if we go to GitHub and refresh once more, you can see Sue's file exists alongside Kevin's in the origin. And I'm afraid that all that was just preparation for this new command we're going to learn. Let's change back to the terminal here and switch back to Kevin's directory to pretend as if we're Kevin once more. If we list the files in Kevin's directory, we can see that Sue's file isn't currently there. This is because Git doesn't update remote copies of the repository with the origin automatically when changes are made by another engineer. The changes need to be pulled down from the origin manually. To do this, we're going to use the git pull command. Git pull origin master in this case. This is different from the clone command, which creates a whole new copy of the repository when used. That would work to get hold of Sue's changes, assuming we first deleted the copy we currently have, but it's overkill, and it would rub out any changes that Kevin had made himself but not committed to the origin. Git pull means go and get any new changes from the origin that I haven't already got yet. You can see here it says one file changed, one insertion. This is referring to the fact that Sue created Sue's file that Kevin has now pulled down from GitHub to join the existing files he already had. If I now do another git status, you'll see it confirms that I'm up to date with the origin, and if I list the file structure, you can see that Sue's file is indeed there now alongside Kevin's. You could probably already see how Git would be quite useful for collaborating on code, but let's be honest, based on the features that we've looked at so far, it's not that different from Google Drive or Dropbox or any other cloud storage system. It's pretty nice that you can commit changes to a historical timeline with a message, but that feature of Git taken in isolation isn't exactly game-changing. It's the last feature, branching, and the resulting ability to create peer reviews that marks Git out as a proper world-class tool for collaborating on code. For this section on branching, I'm going to demonstrate what it actually does in the command line here before we start taking a look at its technical purpose. It's just one of those things that's easier to understand after you've seen it than when it's verbally explained. Okay, so let's go back into Kevin's directory and list what we've got so far. I'll run a quick git status again, and this time I want to draw attention to the fact that it's saying on branch master. Master is the default branch that's created for you when you make a Git repo, so if you never create any additional branches, you'll always be working on branch master. Now I'm going to use the git branch command with a -a to list all of the available branches. You can see there's our master branch, and that Git is also aware that the origin has a master branch too, which is the same branch on our GitHub server. These are the only branches that exist at the moment because we haven't made any of our own yet, so let's make one and call it Kevin. We can make a branch by typing git branch and then any branch name that we like. I should say, by the way, that in a professional environment you wouldn't ever call a branch after your own name. They're more traditionally named after the feature you're developing, as it's more descriptive for your co-workers. But don't worry about that for this example, as we'll be using Git throughout these courses in a more normal manner, and this time it makes sense to call it Kevin. If we use a git branch A here again, we can now see that a new branch called Kevin has been added to the list. To actually make use of that branch, we need to use git checkout. Git checkout means use that branch. So in this case, if I type git checkout Kevin, Git tells me that I've switched to that branch. And if we then list the branches again with git branch A, Git confirms to us that we are using the branch named Kevin. So good for us, but what does it actually mean to be on branch Kevin? If we remind ourselves of the currently existing files, we can see that so far we've got Kevin's file and Sue's file. Now, let's create a second file for Kevin, and I'm going to call it Kevin's second file. Let's save that file here, and as we'd expect, we can now see it in the file system. And if I run a git status, we can see that Git is aware of it and currently tells us it's untracked. So, we know what to do now. First, we add it to Git with git add -a, then commit it to the timeline with git commit -m and a sensible message, and then we can check with git status once more that it's all gone in okay. As before, if I type git branch -a, you can see that I've been on branch Kevin during the time that I created and committed that file to the Git timeline. If we now switch back to branch master using our git checkout master command, and now list the contents of the directory, lo and behold, the file is gone. If we switch back to branch Kevin and check again, the file has returned. And one last time, if we switch back to master, the file is gone. Notice that I'm not changing directory here, I'm still at the same path in the file system, but this directory now has a new magical property, the concept of having multiple versions of what exists within it, depending on which branch you're on. Though I haven't demoed it, if I were to go and modify a file in one of the branches rather than creating a new one, the modification would only exist in the branch in which I made it as well. Each file now has a separate version of everything, independent from the branch it was made from, and really importantly, with its own unique timeline to commit files to. If you're anything like me when I first heard this, I thought, well, yes, that's quite handy, I suppose. But that's just what happens anyway. If you copy a directory full of files, you get a second copy. What's so great about using the branches feature instead of just making copies of my code into different folders? Well, to demonstrate why this is so great, let's check out our branch Kevin again, and now push this branch back to the origin, which we know is basically just uploading the changes back to GitHub. Now, let's go to Firefox and refresh GitHub. You can see now in the branches list that the branch named Kevin has appeared. If we switch to the branch named Kevin, you can see here's Kevin's second file. And as before, if we switch back to branch master, we can confirm that at the moment this file only exists in branch Kevin. You may also have noticed this yellow bar here as well. This is GitHub tipping us off that the new branch has been created, and it's asking us if we want to do something called a pull request. To me, this is the most confusingly named feature on the planet, as if you're using GitHub, it has nothing to do with anyone pulling anything. You can see here there's also a tab called pull requests, and if we switch to it, then along with the same notification we had before, we also have the option to create a new pull request in general. Rather than using the GitHub shortcut, I'm going to choose new pull requests here so we can go through the whole process from scratch. The first thing it asks us is which branches we want to compare, and as we've only got two branches, Kevin and master, I'm going to compare those two. When I do that, it shows me this screen, the most beautifully useful thing in all of version control in my opinion. Do you remember in the original animation I kicked off this section with, the problem was that Sue had no idea what Kevin was up to? Well, this screen is the solution to that problem. This screen is highlighting exactly what differences there are between Kevin's branch and the master branch. The pull request that we've created allows us to merge those two branches together so that the master branch receives all the changes from Kevin's branch. Really, you might think it would be more informative to call it a merge request, and in fact other Git providers do exactly that, but a lot of people call them pull requests or PRs out of tradition, so it's good to be familiar with the term. You can see in this pull request that only one file has been changed, and that it lists the file below with the content that is changed highlighted. If we go ahead and create this pull request here, it tells us that it can go ahead, and again we can go here and check exactly what changes are being proposed to be merged into master. If I click on commits, I can see the history of the timeline for this branch that Kevin has added his messages to, and then when I'm ready I can go back to the place we can perform the merge by clicking conversation. So, to return to the question I asked several minutes ago, why are branches more useful than copied files? It's because they allow this easy comparison that lets a colleague check all of your work before it goes live. And not only can they make that check in the present, but they can also go back and check on any work that's previously been done, as all this information is saved on the timeline. So, to consider the predicament Sue was in after Kevin left, this really doesn't matter anymore, and Sue can wind back to any point in time when Kevin still worked for the firm, and view a concise record of all the changes he made on any particular commit, and she can even undo them or roll back to that point in time if she wants. Even if there were 1,000 Kevins, all having a pint or two at lunchtime and making inadvisable changes to the codebase, Sue would be able to see them all, understand them all, and undo them all if necessary. In fact, it's common practice that changes are not even allowed in the first place until they've been reviewed by a colleague using this exact system of pull requesting, so that before you can even apply them, someone else takes a look at them to check that they are sane. Right, let's complete the merge here as we're almost done. Once merged, all the changes from branch Kevin also exist in the branch master. Each place that you work will probably have a subtly different way they name branches, but as you can probably guess, master is generally used for the production code that goes onto the servers. Other branches might be called develop or given a feature name, just depending on the naming convention the company prefers. Some companies also like you to delete your branch once it's been merged for neatness, but don't worry too much about such details as it'll vary from firm to firm. If we go back to branch master, you can see now that because we've merged, Kevin's second file is now in master as well. Right, one final thing to have a glance at before we end this very longest of sections. I did promise to show you where you can see a history of all the changes you've made to a timeline. So, if you click the commits link here, you can see that history of everything we've done during this chapter. Alright, we've made it to the end of this chapter. 25 minutes of Git is an awful lot to watch in one go, so thanks for sticking with it if you managed to. This isn't the sort of thing you need to absorb in one take and then go and use. I'll be using these skills in every single chapter after this one, so now that you've seen it once and you've got a vague idea what the core concepts are, you don't have to go back and revise this again and again. We're going to learn it as we go. So let's move on to the next chapter, where we have a look at which editor we might want to use and what advantages we can get from it.